can a fast charger be used to overheat your device?
Hey, Ken, I hear you have a story about a bad power attack that affects fast charging devices.
Yeah. So I think we're all pretty familiar with fast charging at the moment. We all are probably used to a scenario where we need to charge our phone or our tablet or whatever our device we need to charge, and we need it now and we need it to be charged now. And so a lot of us have started relying on these fast chargers that will essentially negotiate with the device to find out what's the maximum voltage that the device can take. Is it the standard 5 volts? Is it 12? Is it 20 or even higher? And what will happen is once that negotiation is complete, our devices will then charge at the negotiated voltage. So what these researchers found out, researchers from Tencent, was that if in a certain, there's quite a few of these devices, these fast chargers, where if you put an infected device of some sort up against it, you can actually overwrite the firmware within the fast charger so that the next person or set of people that come and use the charger, it will overload that voltage. So it won't do that negotiation. It might just say, instead of the default 5, we'll do 20. And so what will happen is you'll start to overheat the receiving device, and that can ultimately lead to things like overheating of the device. It might shut off, or even as far as melting, smoke, even fire in some cases. So you can completely destroy a device in this proof of concept case. And what I found really interesting in reading about this was that when the researchers went back and looked, a lot of the fast charging devices, while it comes with default firmware, a bunch of the devices don't have the ability to update the firmware. So while the researchers were able to overwrite the firmware to give a new default to that charge, there was no way for the actual manufacturer to put out an update to limit what that maximum could be on that negotiation. So it's really interesting then to see that people are probably thinking, oh, well, I have this great wireless charger. I don't need to worry about updating software on that. It doesn't directly connect to the internet. And that became a really interesting way of how to actually spread this. It doesn't necessarily have to be the target's device that you hack. It could be an actor could just have a piece of bad malware on, say, a burner device, and they could go up and put it on the fast charger, and within a few seconds or however long it takes to overwrite the firmware, it'll go ahead and update that, and they just walk away with that device. And the next person who comes and decides to fast charge, they're now susceptible to that overload attack, or bad power as it was named. So what they recommended was that the manufacturers need to put in a way so that the maximum voltage, it doesn't exceed whatever the receiving device can actually get. And then the other very simple thing it recommended, and this I guess was a little surprise to me, but I guess it shouldn't be, is that if you don't have a fast charging compatible device, don't use it with a fast charger. So you think, okay, that makes sense, but I guess there's plenty of people who say, oh, I'm in a rush, let me just put my phone down on this charger, and it'll fast charge when their device isn't compatible with it. So while it hasn't been exploited in the wild, to me it was a really interesting case of almost like something out of a movie, where someone comes by, does a little drive-by of just dropping a device, picks it back up, walks away, and no one can really tell that anything happened. But it's just another way of showing that, we need to be wary and understanding of who the manufacturers are of these fast charge devices, or really any device that we're plugging our phones into, or our tablets, or any device, so that we can be better prepared for these types of things.
So basically, in this scenario, the owner's responsibility is on the manufacturers. Am I right if I say that? Like, for example, some sort of overheat protection built into the firmware itself. For example,
right.
Even some bad actor actually be able to manipulate the firmware, but if they have some sort of overheat protection, it switch off, something like that.
I think that was exactly the recommendations of the researchers was to sit there and say, for these manufacturers to go ahead and put a limit on what the maximum is, or on that negotiation of what's the maximum, and making sure that it can't go over what the device can take. Now, one other point was that it wasn't in every manufacturer that they found this problem. I think it said they checked over 230 types of devices or fast chargers, and it came out that I think it was approximately 20 that had this issue, but they shared 8 common manufacturers. So, when you do the math on that, you sit there and say, okay, that's not all of them, but it's enough where, maybe it's we don't know the scale of the availability of those approximately 20 device types. It could be they're the most 20 used, or they're the least 20 used. I guess it's less of an issue, but you don't know how many are out there.
Did they list the number of the manufacturers or the device which are vulnerable?
I did a quick look for it, and they didn't call anybody out.
Okay.
I found a couple of articles on this, and there was no one explicitly mentioned. The one takeaway from one of the articles I saw said that, make sure you're buying your fast charger, or really any device, from a reputable manufacturer. So it could be, maybe it's a third party, or some smaller, lesser known group of manufacturers. But without knowing, we can't say for certain.
Well, definitely I have to watch while charging outside now.
I consider this type of vulnerability a cyber physical system security issue, and I feel a lot of industrial control systems and cyber physical systems are kind of overlooked in cybersecurity nowadays a little bit. And I think if you kind of take this concept and how it's kind of related to cell phone charging, and kind of apply it to a larger industrial control system, like a power plant, that being manipulating firmware to increase more voltage output in a larger industrial control system, like a power system, could be very dangerous, not just only to the people working there, but also to all the endpoints and homes that receive power from the factory.
Yeah, that's a really good point, Chris, and it's something that now that this type of proof of concept thing is out there, just like you said, what other areas could something like this be applied to? So it's an interesting read when we see something that's specific to how we charge our devices, but then when you scale that up to something like how a whole industrial center might run, or another type of, maybe a manufacturing plant or something like that, the repercussions could be real from that type of overload. It's not just a one lost device.